Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Hello, my name is Tom Zimmerman from the RISE Group, and it's my pleasure to introduce May Nagapan from Rochester Institute of Technology. So May actually got his PhD from North Carolina State University. He spent 2 years?
3 years.
3 years in Queen's University in Canada, and he actually collaborated with us in the ESE group in Microsoft Research many times on many different projects. And today he's going to talk to us about his work on App Store mining. Please go ahead.
Thanks, Tom. Thanks for the introduction. Thanks for coming out. As Tom said, I'm May Nagapan, and today I'll be presenting some work that we recently did on truth in advertising. That's kind of the short, sexy version of the title, but it's actually, we're trying to see the hidden cost of advertisements in mobile apps. And this was work that I did with William Halfond and Jiaping Gui from University of Southern California and my student in Queens, Stuart McElroy. So the motivation for our study is that, as you know, everyone now has smartphones. I know that everyone has smartphones because my dad now has a smartphone. That's the rule of thumb that I have. He was one of those people who used to say, children of this generation are just so bad, they're always on their phone, and now he's the guy who's on always his phone. So I know that it's getting very prevalent. There's hundreds of millions of users, probably billions now. There's almost about 200, 300,000 developers developing apps for various stores. The Google Play Store alone has about 1 million plus apps. So does the App Store, the iOS App Store, and Microsoft Store has tens of thousands of apps, and also the BlackBerry Store. But most of these apps are, the way that they kind of monetize is kind of strange, where most of the apps are actually free to download. And I say free to download because only to download are they free. A lot of the apps are now following a freemium model, where they're free to download, and then you kind of pay for using different features or different services in these apps. But till such time that the developer actually gets money from the users for these features, they have to monetize the app some other way. The way they do it is through advertisements. So it's kind of a win-win situation where the users don't actually pay for the app when they download it. They use it, and when they're using it, the developers display these ads, which they get from advertising networks like Google or Flurry or Facebook or any of these advertising networks. And these networks get the advertisements from companies like GM or Hardee's or Burger King or whatever, whichever company that wants to advertise. They give the advertisements and money to Google ad network. And Google then gives these advertisements to the developers. The developers then display these advertisements in their apps. And when users see these ads, and usually it's a specific number, something like every 1,000 times that a particular ad is shown, the developer gets X amount of money. It's not a lot, it's a little, usually it's about a few pennies for every 1,000 times an ad is shown. But every time an ad is clicked, they get paid. It's about 5 cents or so for every time an ad is clicked. So if you do click an ad in your app, you're actually helping the developer. So once in a while, you should actually click the ad just so that you support them. But the developers themselves don't pay anything out of pocket for these advertisements. The users don't pay anything for the apps out of pocket as well. So it seems like a win-win situation where you get the free app and the developers get some money for the free apps. But we wanted to see if free is actually free here. Like, is there just like free to download, are there actually hidden costs with respect to these advertisements? And that was the motivation for our work, is to identify different types of hidden costs and quantify these different types of hidden costs. We wanted to quantify to see if these costs were actually significant or not, what impact they have on the end users. So continuing with our motivation, one way we found that we should look at these advertisements is when we looked at some of the apps, and this is an example app which is it's actually on the Google Play Store called Restaurant Finder. And when we looked at the reviews, one particular review, we kind of zoom in and it says, the ads are so annoying, even before they start making a recommendation for a restaurant, they show ads. I'm uninstalling this app. And I'm sure you've seen these reviews in a lot of apps that you've used. I'm sure you wanted to give some of these reviews for apps that you've used, where the ads were just annoying and you didn't like it, and you were uninstalling it. So this is now a developer not just getting a bad review, but also losing a customer, because the customer is gone. They're not going to come back to this app again. So there are some kind of costs associated with it. So we wanted to see what are all the different types of hidden costs that we can unearth, and then we tried to quantify it. So some hidden costs that we identified were, yes?
Sorry, what does it mean to lose a customer in the mobile space? I mean, either the app is free and the customer doesn't pay anything to you anyway, or the app costs $1, but they can't get their refund.
They can't get their refund, but in the free app, what I mean by losing a customer is when the customer does not have the app installed anymore, they're not going to be using the app, therefore they're not going to get advertisements, and therefore you're going to lose ad revenue from that customer.
Gotcha. Okay, thanks.
Also, even if they buy, it's not a one-time thing, right? After that, they sell features through the apps. In the freemium model, you keep buying things. If they've already uninstalled the app, you're not going to get any more revenue from them.
Okay.
Right. So some of the hidden costs that we have, that we identified are, one is the obvious one, which is kind of like a performance cost. Advertising is still some kind of code that is being executed, right? It still is going and fetching something. There's some kind of code that is being executed along with the code for the regular application. So there is some kind of CPU utilization and there's some kind of memory that is being utilized. But what does this mean that when this happens, does the responsiveness of the app, the runtime responsiveness of the app actually change? So we wanted to measure this cost. The second hidden cost that we identified was energy cost. So when you use an application with advertisements, does it mean that the app actually consumes more energy? And if it does consume more energy, then that means that there's more recharging cycles that are now required. Users may generally know that advertisements or their battery is getting drained faster, but they may not know that it is because of a particular app or because of something inside the app. They may not know where the battery drain is coming from. They may just know that the battery is getting drained faster now. The third cost that we kind of looked at was the network cost. So the advertisements themselves are stored in a central server in, let's say, the Google Ad Network. And the developers connect to this network through the apps and download these advertisements from the network and display the ads on the app. So there's definitely a network-related cost to this. And if supposing, I mean, most of them now don't have, they have unlimited or at least a significant amount of data plan. But when you travel or in other countries where you don't have unlimited data plans, for example, even Canada does not have unlimited data plans, surprisingly. So there might be costs associated with it, and these are significant costs. So there might be actually a dollar cost associated with the network usage of advertisements as well. We also looked at some other costs with respect to not just users, but developers. There's a maintenance effort to keep the app up to date. And it's always, it's one of those things that you have to do, and it's difficult, and you want to keep fixing the bugs. But because advertisement is also code in the application, now developers have some extra stuff to maintain. They have extra libraries to maintain. They have extra calls to maintain. And these libraries change all the time, so you have to change these API calls. So there's extra work that they have to do for code that is not in the core logic of their application. It's just to monetize their application. So we kind of wanted to look at how many updates were being done to just ad-related calls in the application. The final hidden cost that we kind of identified was the impact on ratings. We kind of saw one example review where a reviewer, a user complained and they wanted to uninstall the app. But this past research which shows that the success of an app is closely tied to the ratings and reviews that the app got. So it's not necessary that a high-rated app will always be successful, but it's very, very unlikely that a low-rated app will be ever successful. And we did some research before, and we found out that there's some apps where it's high-rated because you get your friends to go and vote for your application. And there's almost like 90% of the apps on Google Play has less than 10 reviews and 2 versions in a year.
Which is this app that has 28 million reviews?
I think this is Facebook. Facebook, WhatsApp, Angry Birds. There's a few applications like this which, on an unrelated note, we did some studies on these rating systems, and we found that they're not the most ideal ones. Because it's a cumulative rating system, this application, the 28 million reviews, from 4 stars to go to a 3-star rating, needs another 28 million people to give it a 2-star rating. So they can actually release an app which does absolutely nothing, leave it in the store for a day, and still see no difference in their ratings. But yeah.
So like I know that at least on iOS, when the initial set of ratings you see is just for the most recent release, and you have to like specially ask to see the aggregate overall release.
Yes, so I don't know why it is, but iOS is the only platform where they give the ratings of the latest release and the overall cumulative one. Maybe it's a patented thing and nobody else can do that. I don't know, but none of the other stores actually display it. It makes me think that it's not patented because Nokia had a store back when they were still Nokia, and they used to display the version rating as well. And we have a different paper where we say that unless you display the version rating, these ratings are so sticky that successful apps with a lot of ratings can never lose their rating. And on the flip side, an app which has got a significant number of low ratings can never become a high-rated app. And so it's not in the interest of a developer to improve their app at all. There's no need to release a new version. You should always release just a new app. But coming back to this study, so we wanted to see what the effect of these hidden costs on ratings would be and how the developers could actually face some kind of difficulties because of this. So some other examples are, too much advertisements, or there's full screen ads everywhere and therefore I'm going to uninstall, or the advertisements are right in the middle of the screen, they're covering my picture, I can't see it, therefore I'm going to uninstall. So there's a lot of these negative reviews and how these negative reviews can affect the application itself. So having identified all of these kinds of hidden costs, we came up with 5 research questions to actually quantify each of these hidden costs, 3 of which are for the end users and 2 of which are for the developers. So in order to do this, we carried out a case study, like all good software engineering studies should be. And I'll kind of give an overview of what we did in our case study. We first selected apps that we wanted to study. And for this, we went to this website called Distimo, which ranks applications in the Google Play Store. So they rank the top 400 applications in each category. They rank based on the user rating, the user reviews. They kind of do some mining on the reviews and the number of downloads. And based on this, they come up with a ranking scheme. And they say these are the top 400 apps per category. There's about 30 categories, and so about 12,000 apps are there on the Distimo list. But some categories don't have 400 top ranked apps. They have a little less. So on the whole, there's about 10,750 apps. And we mined these apps, every version, every review, every release notes, and all of this on a daily basis. So every day we go to the store and get data on these 10,000 apps. And we've been getting that since January till now, actually. But this study is till August 2014. The data used for this study is till August 2014. So once we we had these apps, we can't. Some of the studies, the calculations that we do for these costs are very intensive. So we can't possibly do this on all 10,000 of these applications. So we picked the top 21 applications based on the ratings and the number of versions in which they've released in the Google Play Store in a given year. So it's kind of small, but these are the list of 21 apps that we looked at. They're sorted by their rating. As you can see, they're all successful apps, and they all have many versions that have been released in that 8-month period. So there's some apps which have released up to 40 versions in 8 months. And if you can see, the categories are all very varied. There's 14 different categories here. So it's not just one type of app that we're looking at. We're looking at apps that are from various categories. So we took these apps and then we removed the ads from these apps. These were all free to download apps with advertisements in them. So what do I mean by ad removal? We actually did a little bit of bytecode rewriting. So we take these apps, which if you've used a Google app before, they have the packaged as .apk files. Then we have some standard off-the-shelf tools with which we can get the bytecode from it. And we know that we are going to look at advertisements from the Google mobile ads network. So we actually looked at the documentation and the APIs for Google mobile ads. And we found out what are all the various API calls for that. And we identified the API calls in these apps. And we went and removed those calls. We could have just removed the ad library itself. But if we remove the ad library, there's still empty calls going on. And that still consumes power, consumes network, consumes performance, and all of that. So we wanted to remove the call once and for all. So we removed these calls and then recompiled them and repackaged them. And after that, we made two kinds of checks. We ran the application on the devices and we manually checked that there were no ads, but still the application was executing as expected. And yes?
Are there no security certificates signing these apps so that anybody can just rewrite them?
We can rewrite them. We can't upload them.
Oh, you can just put them back on your own phone?
Yeah, we can put them back on our own phone. We can't put them back on the store.
Yeah.
So, yeah. So there is a signature, security signature, so we can't upload it in their account.
You can upload it from your own account, right?
We can upload it from my own account. I can create a separate signature for me, and I can upload the same app again. There are actually cases in a different study that we did about 2 years before. We found that there are cases where people download applications, decompile them, change the account for the advertisement network. So if you created the app, I'll change your key to my key, and then re-upload them. And so now whatever revenues that come from the other version of the app come to me and not to you.
You chose to restrict your attention to the top 400 using the Destimo list, but if you consider just apps in general, not considering only the top ones, you might have found an even stronger signal with respect to your 5 research questions.
Absolutely, absolutely. We would have found much higher costs. We wanted to say that even successful apps have this kind of costs. So the non-successful ones definitely could have even more. So we wanted to find the best case scenario had so much cost, so the worst case can be even more. So we did some bytecode rewriting, and then the other check that we did is we connected it to the apps kind of connect to the wireless router in our lab, and we looked at the TCP dump logs to see that we were no longer connecting to the Google mobile apps network, just to make sure that there were no advertisements at all. And now that when we were assured that we had removed the ads, we kind of wanted to generate a workload to measure these costs. And for the workload generation, you can see kind of an animation here that both apps, the one without the ad and with the ad, the workload is the same, but in one case you see an advertisement in the bottom, and in the other case you don't see the advertisement. And we used a tool called Rerun for this, and it kind of records our actions, and then we can replay this over and over again. The criteria for our workload was that it had to be complete. in the sense that we had to finish a particular user action completely. It had to be repeatable. So when we record and replay, we had to get the same actions again and again, and there shouldn't be any non-determinism there. And the sequence should be long enough. We used about 3-minute to 4-minute workloads so that it was a considerable user action. So once we got the workload, we ran the apps with the ads and without the ads for all the 21 apps and measured the 5 different hidden costs. And the results for some of them are here. For the performance, we used the top command in the phone. So we just ran top on the phone every 1 second, and we measured the CPU in terms of the utilization percentage and the memory use in terms of kilobytes, and we actually measured the resident set size of the memory. And we found that indeed there is an increase of CPU utilization and memory. The CPU utilization on average was about somewhere around 50% more CPU was utilized because of advertisements than without advertisements, right? And the memory was about 22% more consumption because of advertisements. But what does this mean to the end user that there's more CPU utilization and memory utilization? Why should they care, right?
Those numbers are relative, or are they absolute?
Relative.
Okay, so
Relative to
50% more than it had used before, but not 50% of the whole CPU.
No.
Okay.
Yeah, 50% more than what they had used before. So what we did is we wanted to find the response time, because that is something that the users would care about. If they actually are trying to interact with an app and their response time increases, then that matters. So we found that apps with advertisements actually took about 7% longer to handle the same set of events than apps without advertisements. That's a considerable percentage when it comes to actually interacting with the application. The second cost that we measured was the energy cost. And for this, we connected the device that we tested on to the monsoon power monitor, and we sampled it at a frequency of 5 kilohertz, and we measured the power used by the app when it was run with ads and without ads. And again, like before, no surprises, we found that there was a considerably higher considerable increase in energy consumed. The mean and the median were around 15-16% more energy consumed when the app had advertisements in it. The top application, so M17, the app, had about a third more power consumed because of the advertisements. So again, what does this mean to the end user, right? So, and about 6 of the apps had over 20% increase in their energy consumed. So what does it mean to the end user? Typically, you want a phone to last at least, the phone's battery to last at least 8 hours, so that when you leave home for work and you have enough battery till you come back home, or you are out in a different country and you're doing sightseeing and you want it to last at least 8 hours. More if you can, but at least 8 hours, right? Yeah.
So a question about the ads are the ones you showed in that simulation were banner ads.
Yep.
Are there some ads that require more resources than others, like animated ads more than just a banner ad? Like, is this Google's code that's using all this energy, or is this the actual ad that happens to be coming in?
It is. So we looked only at banner ads.
Mm-hmm.
We didn't look at other ads, but we assume that it's going to be more for the other types of ads, because we think it's a lot of the energy consumption maybe because of the ad itself being displayed and the network being used to download the advertisements.
Yeah, and I actually had a related question. So I think you answered it. So you focus on banner. I'm wondering how numbers would be different if there's a trend going towards interstitial ads, which are more natural transition points in the game, just to not interfere with game activity. But also, there's a trend within interstitial ads to move to video ads, which I think hardware acceleration will offload some of the, I guess, the CPU cost, but it's definitely more resource intensive than static image.
Yeah, it's going to be more resource intensive, and in terms of the network bandwidth and probably the energy as well, it probably is going to be much more than banner ads.
Well, but if you're playing video already, percentage-wise, you increase to show, a few JPEGs here and there will not be significant.
It depends on where the interstitial ads are. If it's in a video game which is already using a lot of, it's going to be one. But some of the apps that we studied are actually like apps that are like text editor apps, and they have these big banner ads, and they can get these other advertisements as well. They're not very resource intensive to begin with, and they go higher, and it's especially in terms of network use. I'll show you the slide in a short while, but I think 5 or 6 of the apps did not need to connect to the network at all, and the only reason they needed to connect was for the advertisements, right? And so all the network use from that app is from the advertisements. So you would think that, hey, this is a text editor, I don't need the internet for this. And you could be using this in, when I was in Canada and I used to travel, the data pack was, I used to pay $30 for 50 megabytes. And if I was using a text editor app there, I would be consuming a lot of these in terms of advertisements without me realizing that I'm using it.
So if you go to airplane mode, what happens to those ads?
So if you can fool them and you can still use the app without the advertisements, if it's banner ads, I don't know about interstitial ads, whether at that point it comes and it just stops till you get the advertisement and will not let you go further.
I believe it depends on the developer's implementation. Some developers, if they're a larger tier, they implement their own ad scheme, in which case they may have the option to cache certain things and show it even in airplane mode. But a lot of developers will just say, can't start the app because you have to be connected.
Some people might just say, hey, no ad, still continue using, but it's okay. It'll just be code that is executed. Nothing is actually happening because of it, and it will just go on. Yeah.
So the 7% difference in the response time that you just mentioned, does that include the network latency as well, or just the CPU processing?
No, that's the overall response time. End-to-end response time, right? It was just because of the CPU.
Okay, so did we actually study about like network latency as such and CPU processing as such?
No, we did not split the two up in terms of latency. But that's something that we can definitely try to look at in the future, is how much latency is because of network and how much is because of CPU. Okay. And so coming back to the energy, 8 hours if the battery is supposed to last. If the median case that we take, the mean case that we take, then it means that the battery is going to last only 6.7 hours. And if you take the worst case, only 5.4 hours. Which means that it's not the cost of the energy itself, because it's nothing to charge a phone in terms of actual dollars, but it's inconvenience. You might be stuck somewhere without power now and without juice in your battery, and you may not be able to use your GPS or something else, right? The classic example that another researcher gave at a talk was that you're going for an interview and you've set your alarm. Because of all of these things, your battery dies, you don't wake up, you don't go to the job interview, and you lose, you become a bum after that.
Did you check that all the apps you looked at use the same version of the Google Ads library?
Yes, not the same version, but
Like,
close
could there
enough.
be performance improvements that are the reason there's a difference?
They could be because of the Google Ads library that they were using, but they were plus or minus 1 or 2 versions.
Okay.
So they were close enough.
But I mean, to your point, I guess maybe you'll show some data about this. It sounds like a call out, right? Whenever you initiate the video and do call to the cloud, then that's going to cost you an arm and a leg. If you locally pre-cache the whole sea of these ads and then serve them at some later point, then it doesn't cost you much.
It doesn't cost you much, no. But again, it depends on...
It's you're a victim of the scheme in some sense, as opposed to...
Yeah, so the developer, how they build it as well matters, right?
So in general, I mean, developers can do that. Developers tend not to do that. They don't do that is because over time they get smarter about what are relevant ads. So they actually depend on the ability to dynamically request that, and you certainly what you think is the best ad.
And you also have to keep in mind that the developers most of the times don't get an advertisement when they request for one.
What do you mean?
So the demand for advertisements is about 5 times the supply for advertisements. So if you're Angry Birds, every time you ask for an advertisement, you're going to get an advertisement. But if you're the app, Hello World app that I wrote and uploaded, every 1,000 times I request, I probably might get one ad. Google will send ads depending on how many people have installed, how many users are there. So
that doesn't make a lot of sense because, I mean, just because Angry Birds is popular, does that mean that someone who uses Angry Birds is more likely to click an ad? I mean,
so no, it's not just that
users.
factor, right? It's a lot of factors, but they do differentiate the amount of data that ads that are sent to different apps. The fill rate is much lower in some of the apps than other apps. It's not necessarily downloads, right? It could be that there are some kinds of applications where the users are more likely to click on an ad, and those applications might get a lot more than other applications. When it comes to views, again, Angry Birds, there's 100 million people who downloaded it, and at any given time, maybe 1 million people are looking at it, and therefore, as an advertiser, I can reach more people, right? So it's possible, and again, the age group might matter, and there's a lot of context that goes into these advertisements and who should get which advertisement. So again, energy is not in terms of dollars, but more in terms of inconvenience. When it comes to network costs, the way we measured this is we actually connected our device to the wireless router, then we used the TCP dump command, and we measured the total bytes and the number of packets that were downloaded and exchanged between the app and the network. Granted, we could have done this with respect to the 4G network or 3G network as well, but it's not easy to measure the total bytes and the number of packets with that. And there were some concerns that if we did use the 3G network, which is slower than the router, it might take longer for an ad to come, and therefore there might be a higher energy cost and higher performance cost because of this as a ripple effect. But because it was a wireless router, the advertisements were fetched pretty quickly, and therefore the ripple effect costs might be much lower. These costs themselves, the bytes and the number of packets, are not going to change whether we use Wi-Fi network or the telephone network. So we measured these costs, and we got the most for this. I mean, the median was about 97%. Because most of these apps did not actually need to connect to the network. If they needed to connect sparingly. There were actually 1, 2, 3, 4, 5, 6 apps that did not need to connect to the network at all. So the only reason they connected to the network was for the advertisements. So 100% of the network costs were from the advertisements. And relatively, when we just do a percentage, it would be infinite percentage, but this, we kind of said this is max out at 100%. So again, this, and about 16 of the 21 apps had over 80% of the network cost due to advertisements. So we did a little bit of math to see what dollar cost it would be. So AT&T charges about 1.7 cents for every quarter megabyte of data. And so if you use it for about 3 minutes, you're using about quarter megabyte. And if you use it about 2 hours a day, then that's about $20 a month. Granted that this is probably going to be part of your quota, and so you might not go over and actually spend this $20. But if you're traveling and you're having a data pack, then you could be going over your quota because of these advertisements. The fourth cost that we looked at was maintenance effort. So we looked at 2 adjacent releases of the application, and because we were able to do the bytecode analysis, we knew what advertisement API calls were there. So we were seeing how these calls were changing between the 2 releases. And we found out how many releases had these changes. And we found out that there's a lot more change going on related to advertisements. About 22% of the releases, 23% of the releases had ad-related change in them. We saw that during this time, the Google mobile ad network library itself changed 5 times. There were 5 releases for it. So they had to update it 5 times at the very least if they wanted to keep up and get the money. And this is again something that we found from previous research, that in that case study where we looked at about 10,000 apps, a third of the apps actually had dead ad calls. So they were calling ad networks that were no longer companies. So because they were not maintaining the app, they were not maintaining the ad-related calls, they were making calls to networks that no longer existed. Because ad networks is a very volatile market. Everybody is buying over everyone else. Yeah.
The ad networks, were you looking at mediation adapters through AdMob, or were you looking at...
This is only the Google mobile ads.
Okay, so mediation adapters.
Yeah.
So related question, how much of the... So you mentioned there were changes. I know that Google releases updates to mobile ads quite frequently. They tend to be iterative.
Yeah.
So you don't have to necessarily make changes unless you want the new features. And they tend to be separate from the app with their Google Play Services model. So I'm just curious, for the cases where you detected, I guess, actual maintenance effort, how much was that due to?
So there's 2 kinds of maintenance effort. One is that they had to change the library itself. Even if they didn't want to, even if they didn't make all the changes, they didn't make changes to the calls. They might have changed the library alone, which they do sometimes.
Right.
Because Google just says, hey, there's a new library, put this in. They're like, okay, I'm not going to make any changes because it's not breaking anything, but I'm going to put the new library in and release. And we find that as well. We've actually found in a previous study, there's a calculator app which released 7 versions in a particular year, and the only changes made to the app were to the advertising network. So every time as a user you downloaded a new version, all that you were getting were different kind of advertisements. They did no change to the application itself.
This is with the, I guess, the Google Play Services of ads and not the ones.
No.
Okay. It's interesting because I think Google's story is that you can take advantage of feature fixes and feature updates because we're delivering the updates as part of the Google Play Service update and not requiring you to recompile code to take that change. So this is
before the Google Play Services.
Oh.
This is when they actually had to put in the advertising networks into the...
This is third-party advertising.
No, this is Google mobile ads, but they had to physically include a library in their apps and compile it.
So they still do.
Yeah.
But they've offloaded a lot of the core functionality to separate actually running framework on the device.
Yeah.
But they update independently of the actual app. So you don't have to publish, republish apps every update.
Yeah. But okay, yeah, that's true. But this is just the part that's included in the app which is getting updated.
Okay.
Right. Yep.
One of the advantages of keeping your mobile ad network library up to date is that you show up on the updates and you remind your customer that your app exists.
It's possible.
Did you look at the size of the app, every update relative to like the physical size of the app that needs to be downloaded over the network to update it versus the amount of ads it downloaded? So like if it updates itself every month, then it's going to be probably a lot more bandwidth than if it just downloads ads.
Yes.
Or potentially accesses ads that no longer exist.
Yeah. So we didn't look at that. We actually didn't think that's actually an interesting way. I don't know if developers actually do the updates just so that users know that that's an interesting...
Facebook even says it does that.
Facebook does it.
Yeah. We update our app every 4 weeks, always.
Every 2 weeks.
Every 2 weeks, yeah.
Yeah, but then there's...
We're always giving you updates. They never tell you what it is, but you have to download it.
Yeah, but some apps actually do make changes, right? There's this app called Canine Mail, and they release every 2 weeks, and it's because they just have a quicker release cycle. Every time they fix bugs and they're fixing, and every 2 weeks there's a release, right? But there are some applications where the releases are only new. Sometimes it's not just updates of old advertising networks, but they connect to a lot of new advertising networks as well. Because of the fill rate issue, where they don't get enough advertisements, they add more networks to their list of applications.
One other question I have is, did you check about ad downloading over Wi-Fi and over cellular? Because it might be possible for that library to adjust itself. If it realizes it's over cells, it might download lower bandwidth pictures.
It is, yeah. We didn't actually do that. We did only the wireless network. So it is possible that the thing is, we did only Google Mobile Ads network, okay? And it is possible that Google Mobile Ads might download bigger advertisements and more frequently when it's on the Wi-Fi network than it is.
That'd be a logical thing to do.
It would be a logical thing to do. We don't know. I don't know at least if it does that or not. Yeah.
So one more comment about third-party networks. So Google's model is you can plug in these third-party networks to help the ad fill rate problem.
Yeah.
So you can include them on your client publisher app.
Mm-hmm.
They also provide on the dashboard side for the developers a way to configure usage of the adapters. And so even if you included like one that maybe is dead today, you could theoretically, like Google could automate this in one of their features, choose not to try to request any ads from that.
It is, so we're not saying that they may be requesting ads or not, but it is still dead code living in your application, right? This is literally code that is never going to be executed and is sitting in your application. And we found a third of the apps that we studied had this. Because, yeah. I mean, they just realized, there's no downside, so I'm just going to let it stay there. I'm not going to remove it. Why should I? I mean, I don't know what the effects are of keeping code. It shouldn't be logically, it's a space, but there's a lot of space on the devices, and it's not too much space. So we did find that there was considerable amount of maintenance effort even beyond. So 10 of the apps actually had more ad-related changes than the 5 releases themselves. So they were actually changing the calls even beyond the just the library updates as well. And the final cost that we looked at was the impact on the ratings. And for this, what we did is we looked at about 20,000 reviews that we collected from these 21 apps. And we looked for keywords related to energy, to network, to performance, and to ad-related keywords. And we found out that there were about 2,900, or about more than 10% of these reviews that had keywords for one of these 4 events had only 1 or 2 star reviews. So we assumed that they were complaints. People did not like, and they were complaining about a particular thing, whether it was energy or network or performance or advertisements. And we found out the percentage of complaints. So it's only the reviews that are 1 or 2 star, and what percentage of them were related to these different hidden costs, and what percentage was related to advertisements. And we found that with respect to the hidden costs, it's about 5% of the total number of complaints, total number of 1 and 2 star reviews. 5% of the reviews were related to.
How did you know that? How did you know that? How did you link it back to? Was it a manual study, or did you do some kind of sentiment analysis? How did you?
Yeah. So how did we know that it was energy related? Yeah. So in a past study, we kind of did manual analysis and we tagged reviews. And so we kind of knew what kind of keywords show up when they're complaining about energy. So in this study, we just searched for those keywords. And we tagged each review as it was an energy-related complaint, or a network-related complaint, or a ad-related complaint.
And what was your accuracy in your previous work?
In our previous work? Well, accuracy, because we are the ones creating the golden set. And so we manually reviewed it with multiple authors looking at the reviews and tagging it, right? So the accuracy, right now we're actually doing a study and we're looking at accuracies in inter-rater agreement, and it's about 70-80% is Anywhere between 70 and 80% is where even humans agree on a particular review is about a particular thing. So our machine learners cannot get more than that, but because even humans disagree on about 20% of the reviews.
But the ones who ran out of energy couldn't fill out the negative reviews. Think about it.
It is possible. Yeah.
Have you correlated relationship between the time frame between downloading the app and uninstalling the app and the advertisement?
So the thing is, uninstalling we can only know from reviews whether they are going to or not. We actually cannot know if they uninstalled an app or not.
Yeah, okay.
Like Google can know, but we cannot know from mining the App Store whether they uninstalled the app. We cannot know even if the only reason we know they installed the app is because they left a review. Only people who've installed the apps can leave reviews. And we know that when they left the review, they still had the app. But after that, we can't know that they uninstalled the app or not, unfortunately. So even though 5 and 3% might seem like low numbers, they're actually much higher than some of the other complaints that we found in previous studies. So the only kind of complaints that are more than this are crashes, complaints about crashes, and complaints about feature requests, saying that this app is bad because this feature is not there, or this app is bad because it keeps crashing. Those are the only types of complaints that are higher than this. Surprisingly, privacy-related complaints are much lower than this. Right?
It would actually be useful to see like a comparison, like graph showing how this ranks with those things.
Yeah.
It's better perspective.
Yeah. That's actually, we have it in a different study where we have the other complaints and we have this, and we can kind of see, compare it. That would be good actually to show.
But why is it surprising? I mean, they didn't know when there are disclosures, right? This is entirely implicit. I mean, privacy complaints, right?
Privacy complaints,
They have no idea. I mean, energy running out of battery is obvious.
Yeah, but privacy, they don't know that they're losing their...
Install and who knows?
Yeah. In some of the studies, in the previous studies that we did on advertisements, we found that sometimes the app itself is not compromising the privacy, but the advertising library in the app is compromising the privacy. Right? So there were a lot of users who were angry with apps because of the advertisements, and they were complaining about the advertisements, but they were directing it at the app. Right? There was actually one ad network which was so bad that Google had to change its policy to prevent developers from using that ad network anymore. And the ad network was paying top dollar for their advertisements. And so all developers were going towards it. What the ad network does is it starts installing other apps on your phone. So you install an app, and the ad network inside the app will install an app for Chevy or for whatever company is advertising. It'll install their app on your phone. And you actually give them the permission to do that. And now Google says, no, you can't have advertisements like that. They actually had to change the policy a couple of years back so that that kind of ads were no longer possible. But yeah, so the developers themselves did not know that it was doing these kind of crazy things. They just thought, hey, I'm getting a lot of money for these advertisements, I'm going to include it. And then they got slammed with reviews, and bad reviews, and they had to uninstall them. The other kind of study, we kind of looked at what would the increase in rating be if these complaints were not there, right? So we kind of removed these and recalculated the average, and there would be an increase of 0.003 stars. And this number is an insignificant number, let's be frank. But this can be the difference between staying on the first page or in the second page when you search for an app. Because the ratings are so close between some of these apps that this is enough to push you from the first page to the second page. And that matters a lot. Like, how many times do we actually go to the second page of our search results?
How many of these 21 apps were on the first page?
Probably all of them.
Okay. Were they close to the bottom?
I don't know.
Like, is the 0.003 like important for them?
So what we did find is this is a rudimentary thing, but we looked at if you take these 21 apps, right, and if you consider these apps would switch order because of the 0.003, and it could go to the next page because of that. Right? It's a hypothetical thing. It's not actually.
Yeah, they're not in the same categories.
Yeah. So no, I'm just saying again. It's hypothetical, is what I'm saying. Right?
Are they the same price though? Because the price plays a huge.
They're all free apps.
Oh, they're all free apps.
Because they're all advertisement-based apps, right? So in these 21, we didn't have many from each category, right? There's only like a couple of apps that are there from the same category. But I'm just saying that this could be, you could go from the 2nd to the 3rd place because of this. You could go from the 10th to the 11th place because of this.
But is it confirmed that the average rating cannot say the number of reviews, which is drastically different? Like there's a 2x difference between them. Is what influences people's choices.
Sorry.
Look at the number of reviews. There's a 2x difference for the first, the best live quotes in 3D sense.
Yeah.
Yes. Whereas their rating is very close. So is it the rating alone, or is it that plus the reviews plus other things?
I don't know. I don't know if actually the ratings will be affected by the. I know that the change in ratings are affected by the number of reviews that is there. That the more ratings there are, the less change is possible. But I don't know if actually there's more ratings, it means that it'll have a higher rating. If there's more reviews, there'll be a higher rating.
But what I ask is for a person making a selection.
Oh,
do they only consider the rating, or do they also consider the number of reviews?
The number of reviews is also strongly correlated with the success of the app, and not just the high ratings. So yes, they do consider people with more reviews tend to have more downloads as well. So it is true, yeah, because it's 2x, it's possible that they won't look at the small change in the rating and they'll just say there's more people using this, there's more people reviewing this, therefore I'll choose this. So to kind of just summarize, we had 3 different kinds of costs that we had: performance, energy, and bandwidth, and we kind of quantified how much there is. We also found that there's maintenance effort, considerable maintenance effort because of advertisements, and that the ratings are also affected because of the advertisements. So what now? Now that we found this, right? Some of the future directions that we're looking at is, one is we want to do like static analysis or an automated way for a developer to find these costs. We used a power monitor, we used like TCP dump logs and a lot of heavy analysis to actually find out what these costs are, and developers may not have the resources to do this. So can we provide them with a static analysis tool where they run this, and we kind of model this tool based on historical data, and we say that if you do all of these kind of calls, then you're going to get this kind of cost, and therefore be careful, right? And give them a heads up that they are adding a cost to the users. And also try to see if we can make some of these calls more efficient, maybe cache them, maybe get more when it's on Wi-Fi than when it's on 3G or 4G, and different kinds of things. How can we do to optimize these various costs?
I'm going to play devil's advocate. So if I'm a developer, from the previous things, a lot of these costs are hidden to the consumer. They're not really cost to the developer. The one thing that's a cost to the developer are cost rankings, because that could basically impact kind of like the snowball effect of getting users, right? So in that case, I'm going to make a guess, make a leap here. Qualitatively speaking, I've seen most ad complaints are around ad placement, not around performance or impact my battery life or working set. So that's definitely actionable, and that's why I think find developers moving towards interstitial native ads and video ads because they're more attractive and more engaging. But for the other things, as a developer, that's my primary way of monetizing off of users on Android ecosystem or Windows, because we're cheaper than iOS users or even Amazon users. Then why would I invest further money into an infrastructure on costs that are hidden to the consumer, not costing me? And the other thing I would ask is for the advertising networks, in this case Google Mobile Ads, why would I invest in making ad calls more efficient for some of these things?
So I'll answer the second question first. Is for Google, it's in their best interest to give the best product out for the mobile ad network, because if there are going to be costs and there's going to be significant costs, and we've published this result, we've put this out online, and when we kind of talked to the media about this, the way they presented it was, it's cheaper to buy an app than use the free app, is kind of how they were selling it, right? And people, when they see it, they go, wow, really? And if more people get educated about this, it's going to come back to bite them, right? So it's in their best interest to start optimizing it before people realize, and although it might be in the best interest. I guess realize and pay them money, right? That would be good for the developers.
It would be a tragedy, right? I mean,
but it would be good for the developer, I think, because they would definitely make more money when the users pay for their apps than for the advertisements. Because even if they pay $1, if I pay $1 for an app, the developer is getting more money from me than they will ever get from me through advertisements. Because every 1,000 times they get like a couple of pennies. So to make that $1 from just me using the app, it's going to be a lot of usage of the app.
Well, there's a cut that goes to Google or Apple.
Yeah. So I'm saying the cut that comes to the developer is about a couple of pennies for every 1,000 times an ad is viewed. Whereas if I pay $1, they get like 70 cents of $1. Right? I think they get I think with iOS it's like 70 cents. I don't know how much it is with Google.
Sure. With Google it's about 7 cents. I think per 1,000 impressions. Or per 1,000 views, it's about 7 cents per 1,000 views to the developer.
7 cents?
Yeah. For every 1,000 views. Whereas if I pay $1, then they might get 70, 80 cents of that $1, and they might get more money. So it's actually better for the developer and the user if they actually pay for the app. They pay $1 for the app.
Yeah. Have you? It seems to me that ads are going to be difficult to cache because they're highly context sensitive. They're sensitive to your location and so on. So have you given much thought to that? You suggested that as a way to optimize, but I wonder how feasible that is.
Yeah. So it might still be possible that it is context sensual, but sensitive. Context sensitive, but I was going to say contextual, and then I combined context sensitive and contextual into one word. It's context sensitive, but it could be that every day in the morning when I'm in the wireless network, it downloads everything and it shows me the ads through the day, and then the next time I connect to the wireless network in a few hours, it again downloads.
Could be.
Could be.
The thing is that it's not happening actually.
And it's not just one way or the other, but it's going to be a challenge, right? It may be, it's the trade-off. How much of context sensitivity am I going to give up to reduce the costs?
Right. So really, I'm asking. I think that's an interesting question for you to pursue.
Yeah, exactly. When it comes to making it more cost efficient, we need to see multiple trade-offs and see what might be the best option here, right? And to come back to your first question about why would the developers want to do it, I think it's the same kind of reason. Do it now before users realize that it is bad, right? It's one of those things where now they don't realize it, but they're not going to realize it from using the apps. But if more people start finding this out and more people start talking about this and discussing this, it's possible. And they're improving their apps. They don't have to, but it's one of those things where it might come back later to bite them. But you're true that they need not. So that's why we want to make this as cheap as possible for them to use it. Right? They do not need to invest anything. If it's just a static analysis tool that they run and they say, hey, look, this particular version of your app suddenly has like way too much CPU usage.
I guess just looking for actionable guidance here. I guess I would wonder, I feel like we already know where the hidden costs are. it's like, how would we possibly optimize that without, I guess, hurting monetization, right? So like, the reason you tend to ask for ads often is because you know that not every ad's going to be effective, and so you increase this sort of sweet spot of give the user enough time to see the ad that we know it's going to be effective or not, and then after that, display the next thing that could possibly be effective.
Yes, that's true. That's true. It might be better to not just find, but also say what would be a better way to monetize at a lower cost. Yeah.
So do we have any I guess, insights or recommendations on, I guess, what are the kinds of optimizations we make without hurting developer monetization?
Yeah, possibly. I don't know. I don't know yet. This is things that we are looking to explore in the future now.
I mean, just to follow up on this, one of the things we're working on is local client-side ads, where the network cost is aggregated effectively, right? You don't have to call out on every turn, the energy costs are reduced, and you have basically the dual benefit of privacy and higher levels of personalization client-side, right? And that takes care of some of these concerns. That's one observation there. The other observation is that if we just pop out of this a little bit, isn't it the way, isn't this by design that these costs, frankly, they're not as hidden perhaps, and they're designed to be not as hidden because they're designed to be a nudge oftentimes in the freemium model to move people away from this annoying free version that just pops up ads every which way and wastes energy and everything else, to the paid version where I pay $2 and then all of these annoyances are gone. This is just a simple psychological trick, right? You basically eliminate the pain by only paying $1. I think this is all by design, so I'm not even sure that
it could be because of design.
It's just being put through this, pipeline effectively.
It could be by design, but you have to keep in mind that am I willing to pay that $1, or am I willing to not use the app at all and move on?
But I think that's the fundamental question here, which is you've identified the pain points, and you have a way to estimate, if you will, the cost. And so then, of course, there's one of weighing it against the actual cost. And it's not obvious that do you have an answer to that?
No, we don't have an answer to how we are going to optimize it yet.
But it sounds like, again, there's a bit of personal preference that plays into this, but for me, much of the time, I'd rather just pay and not deal with this nonsense.
And there are increasingly more people who are willing to pay and get rid of the annoyance, right? And when that comes through, I think most of this would become irrelevant because they'll be like, hey, it's just now, it's kind of like, we were talking about this work was presented in ICSI this year at Italy, and actually someone was saying, it looks like it's like paying protection money. So you pay that money and then you don't get annoyed anymore, but if you don't, then you get annoyed.
That's one way to look at it. It's another way to look at it is that you lease before you buy. In which case, it's much more...
and that's what a lot of developers are now moving towards, is the freemium model where you use it for free just to see whether you like the app or not. And if you like it, you pay and you buy, right? And if they're moving more and more towards that, yes, definitely this is something. But again, we can still suggest like how much pain can you give before they can actually, they uninstall the app or they pay for the app. That might be something that we can look at as well to see if you start annoying them too much, are they going to pay the $1 and remove it, or are they going to uninstall? So try to figure out where that balance is.
What the sweet spot is, but it's terribly app specific.
It is app specific, it is person specific as well. There's definitely people who are willing to use, and to come back to your first point about hidden costs, a lot of people, when they are told this, they're like, yeah, that is true. But they don't realize it before they're kind of told this, right? Like when we talk to non-computer science people and we say, hey, because of this is happening, and they're like, really? Yeah, that makes sense. That is obvious. It looks obvious, but they didn't quite think of it before. They thought it was a free app, right? Yep.
Why do you think this is less of a concern on iOS? Is it because iOS users have a lower tolerance for this kind of...
I don't know if it is a lesser concern for iOS. We did not study iOS for multiple reasons, one of which being that we don't mine the iOS store continuously. We think that Apple might be more vindictive than Google if they find out that we are actually mining their store. And it's also a lot more difficult to decompile iOS apps than Android apps, just because of the language that they use. There's very good decompilers for Java and almost none for Objective-C. So we haven't looked at iOS, so I don't know if iOS users find it less painful or not. Is the research and numbers publicly available quotable?
iOS users are more likely to pay for apps though, and so ads is actually less effective on iOS because of or less. I should say that. This would be less needed for monetization on iOS because users are more willing to pay for apps.
There's someone here who asked a question. Yes, the paper is available. It's on my website, and you can download it for free, and all the numbers are there on it. So, yeah.
Are there any hidden costs to downloading your paper?
There is a hidden cost to downloading it. No, there is no hidden cost. Thank you.